A warm welcome to everyone. I am Vigneshwaran. Today I am going to present about speed control of synchronous motor. The first thing that comes to our mind, synchronous means constant speed. Synchronous machine is a constant speed within it is independent on load. So why we need speed control of synchronous motor? Because in some industrial applications we need like variable speed. So we need speed control is necessary. Okay. How it is going to done? It is done by varying the frequency. Okay. How we are going to do it by means like it is achieved by voltage feed inverters or current fed inverters like cycloconverters. And why we are going means it have very few losses compared to like induction motor or DC motors for a particular rating. Okay, synchronous machine is a constant speed AC motor. Okay, synchronous motor is a constant speed AC motor. Okay, like let's see how the supply is done for synchronous motor. First, the three-phase AC power is given to the stator, okay, from the main supply. In addition to this, the rotor is supplied by a DC supply. So we need two types of supply for this: AC for three-phase AC for stator and DC supply for rotor. Okay, here the stator is provided by three-phase supply, and the rotor is the permanent magnet which is rotating inside. The rotor is rotating here. Okay, then let's see about the principle of operation, how it is like working. Synchronous motor, they work on the principle of magnetic interlocking. So what is magnetic interlocking? Let's see. When two unlike magnets poles are brought together, that means when we bring north pole and south pole, there will be a force of attraction. This is the basic principle behind magnetic interlocking. In such condition, the two magnets are said to be magnetically locked. If we move one of the magnet, the other magnet will also tend to rotate in the same direction with respect to the previous one. This is the basic principle behind magnetic interlocking. Okay. Now let's see about the working of synchronous motor. So far we have seen the principle. Now let's see how it works. So here N1 is the north pole. When the stator supply is given, first let's assume N1 be the north pole, N1 be here, S1 be downside, and in rotor position maybe will be N2 will be near to N1 and S2 near to S1. So like poles, they are like poles. They tend to repel each other. So N2 will tend to move towards S1 and S2 will tend to move towards N1. Okay. Similarly, when the phase is changed, N1 will become S1 and this S1 will become N1. The rotor position will be same. So now what will happen means first it will try to repel from here. Now it will try to move in clockwise direction and it will try to attract towards the south pole. Here it is given like whatever I explained here is given here. Consider a synchronous motor with two poles. When when the supply is given, three-phase supply AC supply is given to stator and rotor is supplied by a DC source. Okay, rotating magnetic field is produced. The rotating magnetic field causes an effect which is similar to the physical rotation of magnets, such that synchronous speed is achieved. Okay, suppose that stator poles, like I explained, N1 and S1 rotating at synchronous speed. Here N1 and S1, they are rotating at synchronous speed and the direction is clockwise, and then when they are excited by two stationary poles, that is N2 and N2, that is the rotor poles, like attraction is happening. First repulsion will happen because now N1 and N2 they are same poles, the repulsion will happen, and after phase change S1 and N2 will be having attraction, which is explained here. Same thing is explained here. Therefore synchronous motor rotates at only one speed, that is the synchronous speed, and the synchronous speed depends on the frequency. Therefore, when we are giving constant frequency, the synchronous motor will be running at constant speed irrespective of whatever may be the load. So whatever may be the load we were giving, the motor will run at synchronous speed only. Okay, now let's see. Let's come into our main topic, that is speed control of synchronous motor. Like basically the speed of a synchronous motor is given by Ns equal to 120 f by p. Here Ns is the synchronous speed, f is the frequency, and p is the number of poles. As we can see, the synchronous motor Ns depends on frequency of the supply and number of poles of the rotor. So changing the number of poles is not easy. It will change, so we have to change the design, everything, so it will be very tedious. So we will not go with that method. Then automatically what we have is frequency only, so we have to go with frequency only. However, with the invention of solid state device, that is the frequency of current fed to synchronous motor can be varied. That is, by changing the frequency of the supply to the motor, we can control the speed of the synchronous motor. Okay, how we are going to do that means by using a combination of synchronous motor is essentially controlled by two main methods. First one is open loop or separate control method, and second one is closed loop or self control method. In open loop control mode, the motor speed is controlled by independent frequency control of the converter. So by changing the frequency, we can change the motor speed. In second method, closed loop method, the variable frequency control pulses are derived from an rotor position. Based on the rotor position, we are giving the pulse and we are changing the speed of the our motor. Okay, first method is open loop control method. Here from in this diagram, the supply is given, single phase or three phase supply is given, and rectifier is used to convert the AC to DC, and this DC will not be like a good wave, so we have to smoothen the wave. So we are using LC filter to smoothen the wave, inductor and capacitor. After this, the wave will be passed to inverter, and to the inverter, like a function generator will be there. It will be giving the like supplies, so as that it is proportional to the stator flux, so as that stator flux remains constant. Okay, from the PWM pulse that will be given to the multiple synchronous motors. The main advantage is in open loop control method is we can control many motors at a single time. Okay, the same explanation is given here. This method is particularly used where closed speed tracking is essential. That means like there will be a group of machines operating, no, in like a big factories like fiber spinning mills, textile and paper mills. So here they are used, and one point to notice, all the machines are connected in parallel. All the machines are connected in parallel to the same inverter. That is only one inverter, so that they move in synchronism corresponding to the frequency given. That is the same frequency to all the motors. Okay. The phase voltage command Vs is generated through the function generator, where the voltage is essentially maintained proportional to the frequency, so that our stator flux remains constant. Okay, in this mode, the supply frequency is controlled from an independent oscillator. For a given frequency, the machine runs at that fixed speed independent of variation. Whatever may be the load, the motor will run at that speed. Supply voltage and field current, they can be controlled by open loop by controlling the frequency. By controlling our frequency, we can have whatever the speed we want, we can have that. When operating in steady state, if we increase the frequency, then the stator field speed will increase and the torque value will also increase. Okay, this allows the motor to have an increased speed. When the frequency reaches a new value, the motor's field will settle to a new speed after hunting oscillations which are damped by the damper windings. Okay, on the other hand, if we reduce frequency, it will cause the motor speed to reduce as it is proportional to speed, as speed is proportional to the frequency. Okay, consequently the torque value angle will become negative, then the motor decelerates under regenerative braking following the decrease in frequency. Okay, when the frequency reaches a new value, the machine settles at a new speed which will have oscillations and which will be damped by the damper winding. It should be ensured that the frequency must be changed gradually so that we can control. Otherwise, if it drastically change means the frequency will value will increase in a higher way, and the motor may not be in our control and the motor may pull out of step. Okay, the motor can also be started by increasing the frequency slowly from zero value, like slowly we can slowly increase from zero. It will take very much lower current, and it will also have very much high torque. Okay. The second method is self control, that is also called as closed loop operation. Closed loop means here we are having a absolute position encoder to know the position of the rotor in such a way. Based on the position of the rotor, it will produce a command to the controller, and based on that it will give a signal to the inverter, and from that it will give pulse to the rotor, so that the motor we can control the speed of the synchronous motor. This is method is known as self control operation. Okay. A synchronous machine is said to be self-controlled if it gets its operating frequency from an inverter whose thyristors are fired from a rotor position sensing unit. Here this rotor position sensing unit is that absolute position encoder. This measures the rotor position with respect to stator reference and sends pulses to the thyristor. And this thyristor is nothing but the switches, on-off switches. Okay. In this control, as the rotor speed changes, the stator supply frequencies also change proportionally according to the rotor position. Okay, so that the stator field always moves at the same speed as the rotor, so that we will be having our synchronous field. This ensures that stator and rotor field coils they move in synchronism for all the operating points. Okay, consequently, like unlike that open loop system, this self-controlled synchronous motor does not pull out of our control, and it does not have any hunting oscillations or instability associated with step change in torque or frequency when controlled from an independent oscillator, because we are knowing the position of the rotor, and then only we are giving the pulses, so we will not have any problem with that. Okay, this accurate tracking of speed by frequency is realized with the help of rotor position sensor, that is that absolute position encoder. The stator winding of the machine is fed by the inverter that generates variable frequency, variable voltage sinusoidal supply. So here instead of controlling the inverter frequency independently, the frequency and phase output are controlled by absolute position sensor. So here absolute position sensor plays a main role in controlling the motor. So the pulse train from the position sensor can be delayed by giving an external command. By giving some new command, we can also control the motor speed. Okay. So let's see the difference between separately control and self-control motor. In separately control, hunting oscillations are present. In self-control, hunting is eliminated. Here damping winding is needed. Here no need. And here stator supply is controlled by independent oscillator. Here no need, because we are knowing the position by absolute position encoder, so no need of that. And here the advantage is multiple number of machines can be controlled. Here we can control only one machine. Okay, so we are coming to the conclusion. Like, our main topic is speed control of synchronous motor. It can be controlled by using two methods, that is open loop and closed loop. Open loop is the simplest scalar control method, where the speed is controlled by only controlling the frequency of the converter. In closed loop method, the frequency and phase of the output waveform are controlled by knowing the position of the rotor by absolute position encoder mounted on the machine shaft, giving an absolute position of the rotor. Okay, these are the references for this.